The laboratory experiment, the first experiment is modeling and tuning of level process. Level process. Process means a system. In process control, we used to call it as process because it is the marriage between chemical engineer and instrumentation engineer. Instrumentation engineer, no control. Chemical engineer, no process. He knows the process. Suppose a factory manufacturing fertilizer. He knows the process only. He do not know control. They are studying process control. That is different. But it is not their major subject. Major subject is for you. Control. So they know process. What will happen if the pressure increases? What accident may happen if the pressure increases? They know. But they do not know about control. You know. Level process. Level process means in industries there will be units called first unit, second unit. The first unit will give its output to the second unit. First unit produce something. First unit produce something that is given as input to the second unit. It may be a pharmaceutical industry. It may be a pharmaceutical industry to prepare tonic or some other thing. Or it may be a fertilizer industry. Or it may be a energy production, NLC, Neyveli Lignite Corporation, that produce power, Everything comes under process control. All control comes under process control. There, the first unit gives output to the second unit. Its flow rate. Flow rate means it gives some liquid. Say it gives 10 liters per hour it gives. Let us assume. If it gives 10 liters per hour as feed to this second unit, then only the finished product is its output will be good. Quality. You can market it. The quality is not good, you cannot market. So it should be maintained at 10 liters per hour. But this unit, there will be changes. Already we have seen. We want to drive the car at 60 kilometers per hour. But can we control the wind speed? Can we control the slope of the road? We cannot control. That's why we have to adjust something in the car, not outside. Outside we cannot control. Like that, this 10 liters per hour may be varied because of some other parameters that we cannot control. That's why if any changes in 10 liters per hour, then there will be a quality will be degraded in the second unit. So how to maintain 10 liters per hour? For that, what we can do is, this is the first unit that produce approximately 10 liters per hour. Sometimes it may be 11 liters per hour, sometimes it may be 9 liters per hour. I understand this. So what we can do is, this first unit output is given to a level process. This is a level process. Level process. It is given to the level process. Here, I can put one controller here that will maintain 10 liters per hour. 10 liters per hour. Then it is called a flow process. Have you understand this? This is called flow process, not level process. The flow rate, 10 liters per hour is flow rate, not flow. Flow rate is controlled. That way they can control. Or they can control. Another way is, they can keep the level constant. They can keep the level constant. From here, it is coming from here. They can adjust the inflow rate. They can adjust the inflow rate so that the level will be constant. The level is constant, the outflow rate will be constant. You can notice at your home, if the tank is full, you will get the maximum flow rate in your tap at home. The tank is almost empty means you will get less flow rate. So depends upon the level, you will get the flow rate. Depends upon the level, you will get the flow rate. The level is, if you maintain the level constant, the flow rate here will be constant. Am I correct or not? We are maintaining the level. So instead of controlling the flow rate, we can control the level. If you control the level in the middle tank, this is first unit. Here it is second unit. This is second unit. The middle unit is level process. It will maintain the level. That's all. whatever coming from the first unit received by here, and it will adjust the level so that the outflow rate will be constant, not large variation. It is average out the changes. It average. Suppose there is a sudden change from 10 liters per hour to 13 liters per hour means if you put a level control, it will be gradually phased out, averaged out. Small change, 10.1, 10.2, like that it increases, and 13 sudden increase will be averaged out. So this level process is used to average out the sudden changes. Have you understand that? That's why we have to study about the level process. The first process you are going to study is level process. Level process is nothing but a tank. In that we have to maintain the level. We have to maintain the level. How we can maintain the level? To maintain the level, there will be a valve. This valve means, this is called valve. New term. Valve means like a tap at your home. You can adjust the opening. There at home, our hand will be used to adjust the opening. Here it will be a pneumatic signal will be used. Pressure signal will be used to open and close. The valve will be used 3 to 15 psi. PSI will be used. 3 to 15 PSI will be used to adjust the valve opening. How valve works, we will see in some other experiment. So, by adjusting this valve opening, 0 to 100%, you can vary the flow rate from 0 to 10 liters per hour. Let us assume 10 liters per hour. You can adjust, let us assume. So, by adjusting the valve opening, the liquid is coming from somewhere, constant flow rate. But if we adjust the valve opening, flow rate will change so that level can be maintained constant. Do you understand that? Here I want to maintain the level constant because it is a level process. Suppose I want to maintain the level, means what should be measured? I want to maintain level constant. What should be measured? Oh, not opening of the valve. I want to maintain level constant. What should be mentioned? What is the process variable? What is the process variable? Level is the process variable. What is the level is the process variable. Say this tank level means height. Level means height. Height of this level is say 5 feet. Total tank level is 10 feet. I want to maintain 50% of that level. So 5 feet level has to be maintained. So what is the process variable? Liquid level, liquid height. Level you couldn't understand. That's why. Liquid height is called level. Level has to be measured. Level has to be measured. How to measure level? For that, a DPT is there. Sensor is DPT, differential pressure transmitter. DPT is there. Differential pressure transmitter. It is available in the lab. DPT means its output will be 4 to 20 milliamps. Its output will be 4 to 20 milliamps. Current how much varies? 4 to 20 milliamps. If the tank is empty, it gives 4 milliamps. The tank is full, it gives 20 milliamps. It gives 20 milliamps. So this DPT means differential pressure transmitter. One end is connected to the bottom of the tank. Other end is open to atmosphere. This end is open to atmosphere. This end is connected to bottom of the tank. The tank level varies, pressure applied to the DP transmitter is varying. A pressure sensor, DP transmitter is what? A pressure sensor. The pressure sensor output depends upon the pressure applied at one end. What is the pressure at the top of the tank? Atmospheric pressure. So the pressure between the two can be, you can draw level transmitter like this also. It means what? Top atmospheric pressure, bottom tank pressure. That's why it gives output proportional to level, proportional to height. So we can call it as a level transmitter. Here for level transmitter, you are using DPT as a level transmitter. DPT as a level transmitter. So that 4 to 20 milliamps is error signal. We have to generate error signal. That's why this 420 milliamps is given to 420 milliamps is given to controller. Given to the controller. For controller, we are giving set point. Set point equal to, we are giving 5 feet. Set point is given. We cannot give in terms of 5 feet. Here, what is we are getting? 4 to 20 milliamps. How we can subtract 5 feet from 4 to 20 milliamps? You cannot measure because the unit is different. So we have to give set point in terms of 4 to 20 milliamps, or this 4 to 20 milliamps will be read by the controller in terms of percentage, 0 to 100%. It will read like that. If 4 milliamps means 0% level, 20 milliamps means 100% level. Have you understand that? Controller will read the 4 to 20 milliamps like that. Controller will read the 4 to 20 milliamps like that. Have you understand this point? 4 to 20 milliamps will be read as 0 to 100%. Let us assume that if we give 100% input to the valve will be fully opened. If we give 0%, that is 3 psi to the controller, valve will be fully closed. Let us assume. If we give 15 psi, valve will be fully opened. If we give 3 psi, valve will be fully closed. So valve opening can be varied by adjusting 3 to 15 psi. That is given by the controller. The controller output also depends upon the error 4 to 20 milliamps. The controller is P plus I controller. P plus I controller. How P plus I controller works already we have discussed. P plus I controller works based on error. Here I am giving, instead of 5 feet, I am giving 50%. Set point is given as 50%. It means total level is 0 to 10 feet means 50% means 5 feet. So set point is 50%. Actual level is measured by DPT and it is given here. That is also 50% means what is error? 0. If it is not 50% means error is there. Based on that, the controller will give 4 to 20 milliamps. The controller will give 4 to 20 milliamps. That 4 to 20 milliamps is converted into 3 to 15 psi pressure signal. I to P, sorry. This will convert I to P. I to P converter convert that 420 milliamps into 3 to 15 psi. That 3 to 15 psi is connected to this valve. This is the experimental setup. In this, you have to do experiment. Now I will explain. You may get confusion so far. Once again, I am going to tell. This is the complete diagram. If you listen at least now, you can understand. We have to control the level. Say level at 50%. Total level is 100%. You forget about feet and all. Total level is 100%. I want to control at 50%. That's why I am giving set point equal to 50% to the controller. The actual level is measured by DPT. That is, whatever the actual level will be given to the controller. The difference between the two is getting as error. That error signal we are getting in terms of 4 to 20 milliamps. Controller gives 420 milliamps. That is given to I to P. Because this 420 milliamps will not work in the level valve. Valve we need pressure signal to adjust it to opening. That's why this 4 milliamps corresponds to 3 psi. 20 milliamps corresponds to 15 psi pressure. That signal is given to the valve. So valve opening will be adjusted. How we are adjusting the accelerator in the car, accelerator in the bike, like that, it will adjust the valve opening. The controller output will adjust the valve opening. So that level will be maintained at 50%. Now again, we'll come to this example. We want to control the level. That's why level is measured by DPT transmitter. The DPT gives its actual level in terms of 4 to 20 milliamps. If the tank is empty, it gives 4 milliamps. The tank is full, it gives 20 milliamps. It means it gives 0 to 100%. That is read by the controller. You want to maintain at 50%. This 50% is compared with the actual level. Depends upon the error, it will give controller output, say 4 to 20 milliamps. Depends upon that, the valve will be opened. Now we'll come to this. The level is 50%. Initially, the level is 50%. Am I correct or not? Set point is 50%. What is the error? 0. 0 means 4 milliamps. 0 means 4 milliamps. I to P gives how much? 3 psi. Valve will be closed. Valve will be closed. So the level starts draining. But what is the input required? What is the input required? In the level process, I didn't put the outflow rate. Always there will be outflow rate to the next second process. One valve that gives flow rate to the next level, next process. You understand this point? I forgot to put this outflow rate. This is output. Then only you need adjustment. This outflow rate is proportional to level. This outflow rate is proportional to level. That's why you need a controller. Depends upon the level, the flow rate will come. The outflow rate is Q output equal to some constant times level. Square root of H. Depends upon H, the outflow rate will be there. That is given to the second process. That is there. So I want to control the level at 50%. I am measuring the actual level. That gives in terms of 4 to 20 milliamps. The controller read in terms of percentage. The set point is given as 50%. Both are 50%. That's why controller output is 4 milliamps. That's why I to P is 3 psi. Therefore, valve is closed. What should be the valve opening to maintain at 50%? Partially opened. Am I correct or not? 50%. Valve should be opened at 50%. The valve always should be open at 50%. If level decreases, it will open 55%. The level increases, it will open 45%. That's why always it should open 50%. Am I correct or not? Valve always should be at 50% opening. Then only level will be maintained at 50%. That's why that additional input the controller has to give, that is called a bias. That is called a bias. The controller output is equal to the M equal to what is the PI controller? It is based on error. Controller gain multiplied by error. Am I correct or not? Controller gain is called Kc. Kc multiplied by error. This is proportional controller. What is the integral controller? Kc by Ti is a constant. Integral of E dt. Am I correct or not? This is the controller output. If error is 0 means, if error equal to 0 means, control output is 0. That's why this will not work out. Therefore, valve will completely closed. To avoid that, we have to add something that is called a bias. Bias is always 50%. 4 to 20 milliamps means what is the middle value? 12 milliamps. 12 milliamps always, the controller output always must be 12 milliamps. 3 to 15 psi means always 9 psi must be there. If you want to drive the car at 60 kilometers per hour, if your set point equal to PV, that means you want to ride at 60 kilometers per hour. Actual speed is 60 kilometers. Are you closing the accelerator? No wind, no slope, horizontal. Road is horizontal, no wind. The speed is 60 kilometers per hour. Set point is 60 kilometers per hour. Speed is 60 kilometers per hour. What is the error? 0. Are you giving some acceleration or not? You are giving some acceleration to maintain 60 degree. That is called a bias. In controller also should give some bias so that it should be maintained at 50%. That bias is 50%. So that will not comes under calculation. How it comes, we'll see later. How it comes, we'll see later. How to calculate that, we'll see later. But here, what is tuning we have to see? What is tuning we have to see? Here I put some constant Kc multiplied by error. Here I put Kc by Ti, integral of E of t I put. These constants varies depends upon the process. Depends upon the process. For that I will give one example. Today I am driving a old car. Same slope while going from here to Marakanam, same slope. Some speed is changing. That's why I'm giving additional acceleration. So speed is maintained at 60. Tomorrow I am going to drive a new car. Whether I have to give same additional input or different? Different. So it varies from process to process. That's why this Kc by T, Kc, Ti, these constant we have to calculate depends upon the process. That is called tuning. That is called tuning. We have to, depends upon the process, we have to find Kc, Ti. Kc, Ti we have to find. That values we have to enter correctly. Then only the, can I drive new car like old car or old car like new car? I cannot drive. I have to drive as if it is there. I understand this. So depends upon the process, I have to calculate this Kc, Ti. That is called tuning.